And welcome back. So in the last video, our last example had a really big sum to calculate. So we're going to use formulas instead to do stuff like that. So here are your formulas right here. So we've only got 4 of them. So when we've got just a constant, when it's just I, when it's I squared, or when it's I to the third. So this is going to allow us to calculate large sums fairly quickly. Okay, so let's go ahead and try at least this one out. So if you notice, this one doesn't really fit any of these. So we've got to kind of expand this sucker out. So if I FOILed, I'd get I squared minus 2I plus 1, and then I'm going to distribute the I. So I to the third minus 2I squared plus I. And the property that we had earlier says, hey, if you have more than one term in there, you get to sum up each individual term. And if there's a constant, you can pull that constant out to the front. So this middle term, it's going to get its own sum, but I'm also going to pull out the -2. And then the third term, the I, it'll just get its own summation as well. You don't have to do this. You don't have to write them all out separately, but I just wanted to do it just to illustrate the point. Okay, so I to the third. So we're just going to jump straight to this formula here. And whatever the n is, that's what you're just going to plug in for n. So the top number, the 24, is going to go in for n. So we have 24 squared times 25 squared all over 4. And then minus 2 times, and then the sum, oops, I forgot the I squared in there. So the I squared, we're going to use this formula, so it's a little bit bigger. So take the 24, plug it in for all of these n's. So 24 times 25 times 49 all over 6. And then the last one, the I, is going to be with this formula, so plug the 24 in for n. So 24 times 25 all over 2. So you've got some math to work out, but if we worked it out, it comes out to 80,500. So that's how those are going to work. Okay, so how does this really apply to finding the area under the curve? So in geometry, you just got to use the right formula. Like if it's a triangle over a square, it's got a formula for it. But if it's not, we have to take an interesting approach. So what we're going to do is we're going to cover the area, because it's going to be kind of like a blob. We're going to cover it with a shape whose area is equally or is easily calculated. And an easy one to calculate is rectangles, just base times height. No fractions, just base times height. So they have a pretty simple area, which makes them ideal. You could use any shape you wanted, but again, you're trying to be nice to yourself. So once you've covered that area with rectangles and found each of those areas, so each individual rectangle has an area, you're going to add them all up or sum them all together. So let's draw 2 rectangles that will cover the entire region of R. And to make things easier, because we like that, we're going to use rectangles of equal width. And we want to cover the entire area. So 2 rectangles of equal width, so each rectangle has a base of a half. And I want to cover the whole area I don't want to leave anything uncovered. So there's my first rectangle. And here's my second one. So would the total area of these two rectangles be higher or lower than the actual area of R, or the shaded region? Well, it would have to be higher, because you've got excess area that's in the rectangles. You've covered more than just the region itself. So this type of area is going to be called an upper sum. Okay, so example 3, we're going to do just that. We're going to calculate it out. So find the area using an upper sum. So in this first one, it's the same exact region. So I'm going to find the area of each of these rectangles and then add them up. So the area of a rectangle is just base times height. Well, the base is a half. And for this first rectangle here, its height is 1. Okay, then moving on to rectangle number 2. Its base is a half. And I got to figure out the height. Well, the height, I'm not going to just guess at it. I need to get the actual height. So on this rectangle right here, the height is occurring when at this point right there. So this point is occurring at x equals 0.5, or a half. So the height is going to be when x is a half, and so you just plug that into your function to figure out what it is. So when x is a half, you have 1 minus a fourth, or just 3/4. So a half plus 3/8, and that'll equal 7/8. So that's going to typically be how you do these. So you're going to have to plug in x values to determine the heights of your rectangles. And it even worked with this one, because for this rectangle, the height was here. Well, at that point, that was your height of the rectangle. So this is the x value, plug it into the function, and you get 1. Okay, so in the next video, we're going to dive more into this, and we'll see how it goes.